All right, this presentation is a advanced track presentation called Elixir and Phoenix with Liveview. This is a redux of a 3-hour workshop presented by Matthew Lenner a few years ago. You can check out the code that we're going to be referencing on the branch at that GitHub link that is on the screen. That is github.com/Matthew Lenner/gather. The branch is davidgregg/presentation/liveview. All right. So I wanted to talk a little bit about the company I work for. Also, I have my slide notes over here. So it's not that I'm not paying attention to you all. It's just literally that I need to look at something else. So OneFeather is an indigenous-owned technology company located in traditional Lukungan territories. We offer digital and on-the-ground services for strong nation building, including election and digital services. OneFeather supports over 185 First Nations across the country, and there are 220,000 members. Technologically, we're taking a pretty balanced approach to software development. We're a small focused team building a specific set of products, and I'm really enjoying it. It's fun to work at a company where you know the product that you're building, especially in the startup space. It's pretty fun. All right, a little bit about me. I am currently a team lead at OneFeather, and this tech is new to me. I've worked with Scala, Java, Kotlin, JavaScript, TypeScript, PHP, C#, and my favorite was Cold Fusion. But this is just the latest of languages that I've had the opportunity to learn. So I might bring up some possibly wrong opinions because I'm still learning as well. I want to thank my team at OneFeather for helping me get up to speed. So we already talked about the dog in the room and the neighbor who is not in the room. And if you have questions about that, because you just joined, you missed out. You should have been on time. All right, let's talk about some startup challenges because this is Startup Slam. One problem that we have in a startup is that we need to quickly ship usable product to find market fit. And the second problem is that once we find market fit, we really need to be able to scale it up because once we have market fit, users will start hitting our service. And we don't want to do that and have to deal with a bunch of tech debt and rewrite all of our code to handle that scale. Ideally, you also don't want a whole bunch of operations and infrastructure work to get in your way of doing number one, which is quickly shipping usable product. We're going to use Phoenix, Elixir, and Liveview to solve these two problems. And this presentation will basically be us using those technologies to build a small system on top of an application in Phoenix, which is a web MVC framework, similar to Rails, Play, Django, CodeIgniter. Take your pick. This is Elixir's most popular web framework. And we're going to build an analytics system that tracks page views and for a web app so that product can get an idea of who's using what in our app. This is the basic this is like the most basic architecture diagram I can do for a web application. You have a web client that is running in a browser, and it sends an HTTP request to the server. It does some stuff, usually manipulates some data in a database, and then sends back some sort of response, like an OK or a failure or something. And then the web client updates itself. From the analytics perspective, we're going to be doing a collect HTTP request that has the host name, the path name, and the referrer attached to it. We're going to store that in the database and then send back an OK message. All right. So that's basically that. And what I want to do is show you the boring page view dashboard, which is like the end game of this product. Okay. So this app is being hosted at gather.gigelixir.com. And this is just a very rudimentary dashboard that shows the number of page views total, the top pages that are being recorded, and the referrers of those pages. And if you refresh the page, you can see in page views overview, which is where we are, that page view is going up along with the page views. All right, pretty basic stuff, like a pretty normal MVC implementation. All right, Again, if you have questions, I'm not going to see them, and we're expecting Paul to just like stop me, or legit just ask to say something in the little button, and Paul's just going to be like, yeah, go for it. And then we can derail this presentation if we want to. All right, so that's that. But wait, what about interactivity and responsiveness? Where's my JavaScript? Thanks, Jason. That's a really great question. I'm glad you're so eager, and especially during that amazing demo I just did. Yeah, so Liveview actually solves this problem for us. In a traditional Phoenix app, you still have the opportunity to use something like React or Vue or something as a front-end framework to provide a sane way to deal with that interactivity on the web client. Liveview is a server-side rendering framework, which basically takes React and pulls it back over onto the server, which basically lets the server do all of the rendering and then just send the diff back to the web client and update the DOM. I'm going to show you another boxes and arrows representation. This is a more complete architecture diagram, I guess, of a server and web client. So you'll see on the right, you've got the web client, and you've got that React framework manipulating the browser DOM, dealing with web front-end state, and sending off requests back to the server, where in traditional MVC, you'd have a controller that has models and views and utilities that interact with the database. Maybe some of those controllers will ask for data from a third party, another server somewhere else. But in the end, you've got those arrows where there's a request that goes to the server, a response that goes back to the web client, and then the connection is done, and the user can continue to interact with the browser. And then if there's ever another request that needs to be sent, another network request is sent to the server. Okay, so what we're going to do now is take this traditional architecture and then slowly morph it into Liveview so that what we can see is how it's different and where the benefits are. All right, so the first thing we're going to do is we're just going to pull React away from the web client and put it on the server. This is the server-side rendering component, which basically means that there's still a thin JavaScript layer on the web client that does the requests, but all of the DOM munging and the state management is now being held on the server, which is great because then we don't have to write React JavaScript if we don't want to. We could, if this is a Node server, all of this could already be JavaScript, but imagine it's a PHP server or a Rails server or a Python server. Suddenly you're writing all of your DOM interaction and templating and all of that stuff all in the same language. It can drop JavaScript altogether for the most part. Okay, the next thing we're going to do is introduce a WebSocket. I'm not going to go too deep into what a WebSocket is. If you need to know, it's basically a persistent connection between your web client and the server, which means that the server can send messages to the web client without a request being sent from the web client itself. What that gives you, it's called full duplex, and it just is a much more free-form flow of information where the server could send a bunch of information, say from that third-party service at a scheduled time without the web client needing to like ask to see if something's there. So that reduces the amount of network traffic that goes back and forth between the web client and the server. All right. So I hope that's clear. I'm also hoping if there's questions, I hope you're just going for it. If something doesn't make sense, I'd really love this to be a little less formal so you can ask a question. There's a good chance I'm explaining something poorly. So again, just jump in. All right, next. The next thing we're going to do is change all the boxes to circles. And we're going to change all of those double arrows, those back and forth arrows, to completely full duplex communication between each of those boxes. So basically what that is, oh, hilarious record scratch sound. Wait a minute, what are those circles? Also, Dave, you're doing a great job. Shay, I'm glad you came to this talk and that you're satisfied with the explanation I'm giving. Okay, let's talk about processes, which is actually what those circles represent. In Elixir, everything is run, all code is run inside of a process, which I don't want you to confuse with an operating system process. It's not actually that. The reasoning for the reasoning that it's called a process is that it acts similarly to an operating system process, but it runs in the Erlang virtual machine. So all of your code runs inside this process. It's concurrent. Each process is concurrent, so they can be run independently of each other. They're interruptible, which means that the Erlang VM can decide which process gets process time, like to execute its code. And those processes are also isolated, so there's no sharing between each process. Okay. The next important thing is that there's a mailbox. So because they're isolated, each process needs a way to send the other processes messages. So if this process sends the other process like hundreds of messages, this process needs a way to say, okay, well, hang on, I'm dealing with one of those messages right now. So there's a mailbox or a queue where it can go and start retrieving messages as it's ready. And the third thing is that the way that it does that, sending and receiving messages, is basically through a standard interface, send and receive. Okay, so let's get back to this. I'm going to stop and just like jump over. Are there any questions yet at all? No. Good. Okay. Well, not good, but like, okay. All right. Next. Right. Okay. So because Phoenix and Liveview provide a pretty flexible way of structuring your application the way you want, there are still analogs to controllers, models, and views and utilities. But because you have that flexibility, I'm just going to do this. First of all, there's no React. There's this thing called a client process. And that client process, its job is basically to act as a proxy for the web client. So it's going to mimic that state. And so that process will live for the duration of the WebSocket connection. So if you're a user to our app, you will connect, and it'll stay alive to deal with requests and to handle the state. And it abstracts away those diffs, those DOM changes, so you don't have to worry about that. So we don't ever actually interact with this process. This isn't code we write. The rest of the processes in this bundle, we do. Well, some of them we do, some of them we don't. But all of the analogs of our controllers, models, views, and utilities live here. And Phoenix, the framework, gives us a huge number of tools to make sure that this process can be something like a controller, or we have a database access layer to abstract and run queries on the database. So there's all the tooling that you have in a traditional MVC framework along with Liveview. All right, so let's show some of that interactivity if we go back to gather.gigelixir.com, gigelixirapp.com, sorry. Where are you? You're here. Okay, so what I want to do is just go to the home page. And you'll notice this is pretty basic. We've got some stuff up here, but this, you got 3 links to circle, square, and triangle. If you click on them, you can see that the shapes change. Now, you can also see that the URL is changing. We're patching the URL, and you can see stuff changing. The interactive piece, the thing to keep in mind is that we have this counter down at the bottom, and that's there basically to show you that we're not doing a full page load here. This acts a lot like a single page app. It actually acts exactly like a single page app, with in my opinion, a little bit more, like it feels a lot better. I mean, it's not a very useful single page app, but still.
I got a question from Jason here.
Yes.
He's wondering in that diagram, which part is Phoenix and which part is Liveview?
Oh, good question. Let's jump back, because the demo is pretty much over there. Okay, so in this quick, do you want to, Jay, do you feel like talking or no? Good, let's get him in.
Hey,
let's get back on the mic.
Hey, Dave.
Hey. Yeah.
Yeah, sorry, you had this MVC portion. I was curious where Phoenix comes in and where Liveview is, and I guess where React is React. I guess you have React explicitly defined here, but.
Well, you do, but like this is sort of a transition slide. So this is sort of the diff, right? So if we look at server-side rendering, you have something like React working on the server, and then that deals with. So let's go back one more. Right. So this is your traditional MVC. You've got like controllers, views, models. Phoenix has all. Let's go back one more and one more. Phoenix is this. This is like the Phoenix MVC framework. You can choose how to do your web client. You have templates that live in your views here, and those get rendered here. And then you can use React if you prefer to do like JSON responses and have a pure API if you want server. There's like it's basically what you'd expect from like any other MVC framework. So that's Phoenix. Liveview is basically if you took the server-side rendering over here, used processes across the board, put in a WebSocket, and got rid of React in favor of like Phoenix's client process.
So it's no longer an API. It server-side renders the React and then
That's
sends
right.
back up?
Yeah. It's not like actually, like React is now no longer part of this, right? Like you're using only Elixir language to write your application. So like one of the cool parts about this app, I didn't write any JavaScript to do this. This is all Elixir. Does that answer your question?
Absolutely. I have many more. I don't want to hijack your presentation.
That's like half the reason. I'm pretty into the hijack. All right. Oh yeah, Jay, you have another question.
Yeah, real-time quotes.
Yeah, exactly. How can we handle events from other systems? So one of the cool things that you have, let's go back to this. I guess I don't need to because I have the actual thing. One of the things that you might have is an event from another system. Let's say you've got, well, I'm going to actually get into it. You've got a system that sends events, right? Phoenix PubSub is built right into the Phoenix framework and supports all that for you. You don't have to reach outside of the ecosystem to handle that stuff. In a different MVC application, you would, in a traditional like PHP land, you might do some sort of polling or use a cron job to query a database to see if new events have landed there. You might be using Kafka to pull in events from that system and things like that.
It's kind of like GCP Cloud Functions?
Yeah, exactly. So yeah, that's a really good example, like a Cloud Function that would post to your web application. You'd have to provide some sort of like interaction there. With PubSub, let's say you receive one of those events, it'll basically do the publisher and subscriber routines built right in. So let's take a look at that. This, you may remember, is the last slide that we had of the architecture. We're going to move the database over to the left and take one of those process bubbles and pull it down to the right and attach something else. And not just something else, let's do api.catsOnCats.com. It's some third-party service that just like sends intermittent cats. And what this process's job is wrapping that API so that you can always know when there is a cat. All right. So when the challenge that we're going to try and figure out is when this process receives a cat, how do we get that cat over to the DOM in real time? We don't want the user to have to refresh the screen. We don't want to write JavaScript, and we want to be able to push that cat from this process through whatever data processing we need to do over here, and then back to the client process through the WebSocket and onto the DOM. And the way that we do that is with Phoenix PubSub. And it's remarkably simple to use. One process over here can subscribe to a topic called Sometimes Cats. This process here can then broadcast to that same topic, Sometimes Cats. And the result is that you get cats all the way down. It's literally that simple, and it's about 2 lines of code to use to have a publisher system. And all of this is really, to me, this is really leveraging Elixir's processes because they're concurrent, because they're built to be concurrent. You're not adding layers on top of a language to get there. It's literally built right in. And Phoenix is taking advantage of that. And so everything feels really like clean. Like it's like, oh, this was meant to be here. And it doesn't feel like a kludge or a hack. All right, so let's do a demo showing that super exciting real-time page view dashboard. Paul, how many users do we have? How many people are viewing this presentation?
13.
13. Okay, everybody, if you can, go to gather.gigelixirapp.com. Just load it up. I'm going to give you some time to do that while I bring this up. Okay, you should land here. So what I'm going to do is I'm going to go to the overview, the dashboard. I'm just going to leave it here. And if you are on your mobile device or something like that, hopefully, you can start to see refers start updating. And like, I'm not, my hands are off. I'll keep my hands away from the keyboard so you can tell I'm not refreshing the page or anything. But you can see like the different pages are just getting exploded. The refers from nowhere are huge because people just typed it in. But I was really happy to see that refer from Hopin show up. Somebody, I actually don't know how you got there from here. That's really neat. Cool. This is it. This is the cool thing. Like, I'm not doing anything. There was no JavaScript written to make this happen. It's all being rendered on the server. We could look at the network traffic, and you would see very small messages over the wire. Phoenix does a fantastic job of keeping the diffs small. So I think there's other server-side rendering frameworks that basically send this huge ice cube of data down the WebSocket throat. Whereas this is just like, it's literally just, all it sends is like that page view for Hopin on the right. It's literally just sending like that. You're not re-rendering the whole page. You're basically just patching the DOM as small as possible. So to give an example of like why this is neat, or an example of how this was used, someone built Flappy Birds in Liveview, and it was decent. Like, I played it, and I wasn't any worse at it than the other implementation, which is pretty cool. All right, this is the juice of this demo. So if you leave right now, you could, and I hope what you've gotten out is that like the Elixir ecosystem provides a way to like make really, really rapid development easy. It gives you the interactivity without having to reach for other frameworks, and it gives you tooling to really like scale up where you need to. If you decide, actually, I have more slides for this. So this could be the end. I wonder if we should do a poll. Paul, can we do a poll?
Unfortunately, I can't do a poll.
Can I? I could do one. I didn't try. I don't know how to do one. Let's go to chat. We'll just do an informal poll. The direction we're going to go here. What time is it? How are we doing? Oh, we have 5 minutes.
Lots of time.
No, we have lots of minutes actually. Good. So not quite the end. And I know that JMike's having a lot of fun right now. And it seems like this might be hard on the database. So that is something that Jason would think about. How can we make this scale better? So that's the next thing we'll do. I think we're going to go for it. So I want to talk. This is now we're basically diving out of we're moving from the shallow end into like the deep end, and I don't want to confuse what we're about to talk about with like that first part of startup problems where it's like we need to release usable code fast. There's some like I want to underline a few things. You don't need a bunch of other developers to figure out how to write React or JavaScript. You can just have Elixir developers who know a little bit about JavaScript. So your pool of developers is actually like a lot smaller. And honestly, I have worked. I prefer typed languages from my background, and I'm enjoying writing Elixir immensely. It's a totally different paradigm and uses some of its language features to make the dynamic language work a lot better with safety. All right, so let's talk a little bit about fault tolerance. We're going to get into, wait, does anyone have any questions? Let's stop. Let's take a quick break.
When you say fault tolerance,
Jonathan, that is not a real API. I'm going to build it one day. Jay, are you
But
still?
the domain name is available on name.com.
Hey, Dave.
Hey.
When you are talking about fault tolerance, what does that mean? What do you?
That's a good question. Okay, so let's talk about like a memory leak in a Java process. Let's say somebody's writing Scala or Kotlin or Java or something that's on the JVM, and they forget to free something up or something like that, and suddenly like that piece can bring down your entire process. Or in PHP, somebody writes some code that in the certain edge case will die, and that code needs to stay around. So let's go back to I'm going to go back to the diagrams. Let's go here. Without the cats. No, with the cats. Cats. Right. So one of the things that's interesting is you've got this process here that's basically always connected to api.catsoncats.com. So this process needs to live for a very long time. But what happens if, for example, it gets a dog instead of a cat and it doesn't actually know what to do with the dog? Like api.catsoncats sends some weird data once and this thing fatals, like it experiences a fatal error. What would happen in a normal system is that would just be gone. And then this would stop publishing, so this would get no more messages, and suddenly our cats are gone. We might not know why. There might be a log in the app. You might have some alerting around that stuff. Fault tolerance is a way to make that thing tolerant to that kind of fault. Does that answer your question, Jay?
Yes. Yes. Thank you, Dave.
Thank you. It's a great question. And probably I forgot about it. All right, so let's go back. So the way that Elixir handles fault tolerance is with little servers. They represent, hang on, I don't want to say this wrong, a specialized process that basically has a way of watching other processors. So it's kind of like a watchman. All right. I'm going to add a bunch of stuff and then just stop. So what we've got here is I'm showing the same web client and the same server. On the server, we're going to add some supervisors. So the collector supervisor, oh, hang on, let's just go back. Back. I'm going to go to, no, I'll keep going with this, it's fine. It's fine. So if we're going to add some fault tolerance to this collector, let's say what we want to do is start batching our page views so that it doesn't hit the database so hard, which sort of goes back to that question that you had, Jason, earlier. So if we wanted to change this so that we could start batching those requests up and make sure that those requests can be recorded to the database, this is a strategy we can use. So we're going to add a supervisor that basically watches this specialized process that is the collector. So we'll send all of our page views, instead of directly to the database, over to the collector. The collector, every so often, oh yeah, here we go. So we'll send those page views to a queue in the collector. And every so often, we're going to send that queue over to a process. A process that handles all of those items on the queue. I'm starting to overload the word process. There's a processor that is a process whose task is to take each of that queue and insert them into the database. And so in this way, what you can do is decouple the page view itself in the web client from the database, in that we have a little middleman that stands here and every so often will release all of its page views over to the processor so that it can be written to the database. Okay, so the reason this is interesting, let's say that processor has a dog in it. So we get all the way through, the dog gets sent, or not a page view gets sent from the web client somehow. Say a malicious user decides to hit the /collect endpoint or load a different, just send some different data that we're not expecting. And we don't do anything about it until we actually try to process it and put it into the database. And this errors out. The processing supervisor will actually notice that the process has died and respawn it. And respawn it until either we can handle that error, or it will incrementally back off and stop trying to like take down your system. All right, so that's kind of the next step. And if you're really paying attention, all we've built here is basically RabbitMQ without having to actually bring in any ops work. So we have a in-memory queue that we could make durable if we really wanted to. We could start writing the queue down to disk or to some other system if we needed to. And in a startup capacity, like if you don't have like 100 developers or even 20 developers, you might not have time to figure out all of the ops related to implementing RabbitMQ, to bringing Redis in. You might not be able to waste that. It's less time working on the business and more time working on the infrastructure, which isn't great for a startup. So we could try to do this live. We could try to actually code this up in, what is it, less than 15 minutes, 12 minutes, I suppose. Do we want to try? This is the next poll.
Yeah.
We'll go with chats. Okay, Jason might want to. There's 12 more people. All right, that's 2. Let's try it. Again, I'm a team lead, so this will either be completely on any. I think Matthew's here, so we can just be like, Dave, facepalm. This is horrible. One of the things that I changed was that we're going to be deploying this to Gig Elixir to actually test. But let's see what we want to do. It's also nice to sort of look at some of this code. So first, let's show the templating language. So this, let's see if we can make this a little less weird. Right. So this is the page lot. I'm going to have to get you all up to speed rapidly.
The text is coming in a little bit blurry, Dave. You might want to see if removing your webcam video might increase the bandwidth.
I don't know how to do that. I'll make this bigger. And so I'm going to slow right down.
Sure.
Okay. I think that size should be okay. So this is the router. This is one of the Phoenix. This is a Phoenix nicety that comes along with Phoenix. And so you'll notice here that there's basically a way to define our endpoints and which module, Elixir module, will have all the logic to deal with that request. So root goes to a page live module, which I have here. Each Liveview module has a mount, which allows you to set some default state, and then ways to handle parameters and events from other processes. All right. What we're trying to do right now, what I'd like to do is change over from using the direct write to database and switch over to that supervision tree that has the collector in it. I've written most of that code already, so we're not actually going to write the collector code. I can show it to you. It basically, we're going to use this function to enqueue a page view, and then we're going to push that into the a push message onto itself. So we're going to send ourselves a push message, which we will handle, where are you? Down here. We'll take that page view, put it on a queue, and every 10 seconds, we're going to do work, which will persist that queue by sending that message over to the processor to run with the queue. So that basically is the code version of that slide back here. Okay. I want to keep it on. So the place that we're actually recording let's go back to the router. So the /collect endpoint is where the page views are being sent from the client to a normal, this is just an HTTP request with a little bit of Liveview juice to make it a little bit better for the different interactions in Liveview. But this controller is going to handle all of the the front end sending us those page views. So let's go take a look at that. You can see right here, we're using analytics.createPageView. And if we go look at that, what it's going to do is take the raw attributes from the web request, create a page view struct, and then insert it directly into the database. And then we're going to broadcast to the PubSub that we did that work. So that's like the full loop of taking the web request, putting it in the database, and then broadcasting to all of the overview pages that we did that work. So all we have to do in this case, this might not be as illustrative as I want to. I'm going to make that a bit bigger. All we would really have to do, if I go to that collector, I'm going to move that over here so we can see both. All we'd need to do is, instead of doing a repo insert, we can do gather. Right. So what that's going to do is, instead of going to the analytics thing that inserted it right into the data to create the page view and then insert it, instead what we'll do is, oh, actually, hang on. That's not what I want to do. This is in the analytics thing. Let's go back. Undo, undo, undo. Going the wrong direction with this. I want to replace this create page view, and we want to enqueue the page view here. So for real is what I'm going to do. Is it showing up now, Paul? Can you read it if I go slow? Okay. That's going to need a page view instead of attributes. So what we'll have to do, and keep this open for a second down here. How are we going to do this? We need to create a page view, so we're going to have to take the attributes and create it there. This might get ugly, and Matthew might be shaking his head. That's fine. So we'll do this to create the attributes, and then we'll pipe the result. So one of the cool things about Elixir is this pipe operator that allows you to take the result of this function and just pipe it Linux style into the next function. And so now that this will create the page view struct. I'm pretty sure. Ooh. Hang on, I think there's another thing we could do. Yeah, no, that's fine, isn't it? Oh, actually, there's another. That's the one I want, validate page view. So what that'll do is create that change set. So it's not create page view, it's validated page view, which will create a valid page view. There we go. And then we can, call analytics and queue page view. Let's do that. Okay. Okay, that should do the job. Close this. Right, okay, so we take the parameters, we create a valid page view struct, we push that into the enqueue page view, and it doesn't want to work. Why don't you want to work? Okay, because enqueue page view will actually return just okay. Chance to catch up with validation. I know you want to work. Oh, this actually returns. Yeah, okay, sorry. So what we want to do is do that, and then we'll continue. Here. There. Ugh. All right. There. Okay, great. All right. So what we've done is we've changed the insert to send to an enqueue into that queue. That will run to the collector, cast to the collector a push. We already went through the code here a little bit. Basically sets up a queue and pushes it there. And then every 10 seconds, it's going to send that work over to the processor. So let's see what happens if I push this code live. Need to check this in actually. This is not representative of a commit anyone wants to do. But this will get it going, sent up to Gig Elixir. We can watch that process if we want to. So that's done. Okay, while this is running, while this is pushing, we'll hope it works. I'm going to ask if anyone has any questions.
I'm curious to see what client code looks like.
Oh, sure. The client code? Like the
HTML
actual
page
source?
itself.
Like you want me to go to the dev tools?
No, the actual index.html. What does that look like?
Oh, fair. Yeah, good question. Okay, so there isn't an index.html. What you do have is a router. So basically, what the underneath a few layers, Phoenix uses an Erlang web server called Cowboy, or Cowboy implements an Erlang web server. Cowboy basically wraps HTTP requests and pushes them to another library called Plug, which is an Elixir library, and the code literally runs through this router. Instead of like, you know how what's your background? What language do you use?
Python, Golang, JavaScript.
Yeah, fair enough. So most of those have like some sort of like equivalent of main, right? Like a
Yeah.
like index. Yeah. And Matthew, you might want to pipe in here if I'm getting this wrong, but from what I understand, there isn't one of those. There's, well, that's not expressly true, is it? Let's dig around. Yeah, so we can take a look at this. There is gather.ex, which is just a module that doesn't actually do anything. That's an empty module. That does nothing. Gather web defines a controller. There's some magic in here that like I don't quite understand, like how, but I don't think there isn't like a main. Can you look at the pro?
So I think, are you asking? Hi.
Thank you.
Are you asking like what happens when you view this page?
Exactly.
I think, okay. If you like from the router, maybe Dave, start there.
Yep. I'm going to just do double here. Okay.
Okay, so we've there's this page views down on, I can't see what line that is, but
38.
page views / overview, and it's handled by this page view live overview module. So if you open that up.
Mm-hmm.
This is like your, it's sort of like a combination between a controller or like in like a, if you were using React, it would be like a state management component, and then there's so basically like a view controller in it. So when it mounts, it subscribes, it sets up some state, and then it returns that on with that. So the mount function is mounting, and then handle info is because it's subscribed to the analytics. That's a recorded metric, and so how do we react to that event? So we update the views, pages, and refers, and we just increment them by 1.
So that's like the controller. This is like
then if you, well, and then if you open up the template, maybe that's the that's the next thing to show. So, you know, it looks like a typical HTML template type thing where
and does that answer your question?
It does. It actually does, yeah.
Oh, right on. I thought you were going the other direction. Like, I can't tell you what comes before the router because it's pretty abstracted, which I think is okay. All right. Okay. So the deploy is done and it works. So if everyone goes back to their Gig Elixir app, I'll leave this up. Just start mucking about, and you'll notice right away that things don't change right away now. And instead, what's going to happen is it's going to batch up every 10 seconds. You should see a bunch of changes. So if everyone just goes in and starts playing. Now, some of the things that I've done here to make it a little bit more interesting is that I'll show you a presentation. It's like a presentation hack where I put a sleep into the code so that you could see things a bit slower. It might work against me in this particular demo, but let's find out. Let's go find it. So in that processor code, I would like to this is the run. So when this process is kicked off by its supervisor, it's told to run the run function. And so what it's going to do is take those page views queue and insert them into the database, which is literally just like the same call that we used to have. We're going to insert the page into the database. And then we're going to do a delayed broadcast by 250 milliseconds, which literally is going to sleep before it broadcasts. So every 10 seconds, we'll get a batch. And then every 250 milliseconds, we will broadcast that out to the PubSub. Yeah. And what we can do, I don't know if we really have, how much time are we done? We're done, aren't we?
Minutes left.
Oh, okay. I want to stop for questions, but I mean, we're kind of just hacking around now, so that's good. And Matthew's on, so he can answer any questions I miss. I'm going to make this bigger. I'm just going to show you the collector code and the supervisor code. Show you there's not that much to it, really. I wish my screen was a bit bigger, but like the processor is one function, run, and then broadcast, and like these are just implementation details. Start link in collector is how this gets registered with the supervisor. Init is called when the supervisor starts this process. This is our public API function that we call from our logic. And the rest is implementation details. So again, like not a lot going on here. Handle cast is when to handle, it's kind of like the receive function. If you remember back to our processes, it's just abstracted, has some better stuff. And then the supervisor is dumb simple. I'd like to show that a little bit. So when the supervisor started, you can define which children, like what it's actually going to supervise. And then on fail, you can tell the supervisor how you want to deal with that failure. So if the collector process dies, 1-for-1 will just say, start a new one. If there's other strategies you can use, though, that are like, okay, if this one dies, restart all the children. Or there's another one that's like, if this one dies, restart all the ones that we started after this one. So there's a bunch of different strategies depending on what you need. And these tools, the supervision trees and the processes, basically will allow you to scale up your application without needing to reach outside of the Elixir ecosystem right away, which gives you more time to deliver business value, which gives you more revenue to maybe hire an ops person later when you eventually might need to scale this out instead of building it. And that is the end of my presentation. Thank you.
How would you, like, can you go back to diagram? I think you're just about to switch there, but like talk what that would look like in traditional, like
Oh, yeah.
What would all of those bubbles be in a web app architecture?
Oh, that's fun. Let's do that. Give me a second. Still sharing my screen. Yeah. Okay, traditional web architecture, and some of this might need to get used again, but like you've got a web server here. Hang on, I'm just going to grab.
You could show you.
Oh no.
Around and say Redis, Kafka.
Yeah. Okay. Yeah, we can.
Worker.
That's, yeah. So I said one of the things I said earlier was that this is basically like a RabbitMQ clone. What we're doing here. If you needed like some sort of more durable option, a lot of the times in my career, we've reached for Redis, we've reached for Kafka, we've reached for RabbitMQ, and those are like legitimate options. But so what you'd have is the web client would. Now, Matthew, is your question like how we would do this? Like, who cares about Liveview in this situation? It's just like, how would you deal with this system?
Yeah, like to me, each of those things are server.
Yeah, for sure. Okay, so depending on the tech you pick, you may or may not have a supervisor to deal with the workers failing. So in PHP, you have, oh boy, what's that called? Gearman, that gives you a bunch of PHP workers that are basically like separate actual OS processes. If one of those things dies or errors, all you get is the message gets sent to another queue, and maybe you can inspect that, but you have to like write all your own tooling for it. And it's not going to, there's no retry mechanism that you can get, if I remember correctly. Redis would be another option where, for example, when the web client sends a page view, the controller or the collector or whatever, your logic could enqueue that into Redis, and you could have another PHP service running on a cron in Linux that would periodically go check Redis for that queue and process it into the database. Now you're talking about spinning up another VM or a container to run that specific microservice to process your Redis queues. You could go full bore and get Kafka in there, so you get a durable queue that's replayable. That's like over the top, but like pretty fun these days, like trendy. All those things require a little bit more effort, right? Like we had three files to deal with a bunch of this stuff, and gives you a lot more flexibility and insight into what's going on. Can you think of anything else that I might have missed as far as like other services that you might need to replicate this? Uh-oh, did we lose Matthew?
No.
Okay.
No, I'm here. So for me, this is like, I think what's interesting about this versus scaling web apps traditionally, or at least from my experience with it, is single-threaded language like Python or Ruby or Node. To do this sort of off-band processing, you basically have to reach for some external queue. Then you introduce another ops dependency, and then that also has sort of that. If you have 2 points of failure there, I guess 3 technically. You have your web server that could go down, the network between. You have your queue backing thing that could go down in the network between them. So there's like a bunch more stuff. Yeah, for sure. Whereas with this, we like something that like some endpoint that becomes overloaded. You can sort of just throw a queue in there with
yeah, that's true. I mean,
Erlang has a queue abstraction.
Oh yeah, for sure. I would put on my Node hat, which isn't mine, but like my friend's Node hat, and say like, okay, well, Node has like async await. You could start doing that there, but again, because it's still single-threaded, I think, still. Like the benefit of Elixir is it's actually built to be concurrent, like on purpose, like at its foundation, which provides like a better implementation of this stuff than say even other languages where you can hold state. Yeah. All right. Oh. Okay, I'm going to stop sharing. I'm going to stop sharing my screen, I think.
All those services you talked about are actually knee-jerk what I would reach for in my toolbox. So this is an interesting, different perspective.
Yeah. So, I mean, at previous jobs, I've had discussions and debates with developers about like build it yourself versus like build versus buy almost. Like, well, the argument would be like, well, Redis does what it does really well. And like, that's true. That's true. But like in the context of like a startup where you really don't have, you might not have the time to stand all that up in a way that it's resilient and fault tolerant with like maybe an extra node or two if that goes down, you know? Yeah, it's kind of like you could get that done in like the code that I showed you. You could get that done in like an hour, kind of idea, and it gets the job done today, if that makes sense. So you can't throw those other tools out, but what this does is allow you to have more runway, like with what you've got, to get more product out the door. No, good question, Jonathan. How does Elixir? Is this the first question that's typed? Yeah. Okay. How does Elixir scale horizontally? Is the PubSub single machine? If you remember when I was talking about processes, I said there's this one other thing that is kind of like not germane to the presentation, and that is that processes are location transparent. So the way that Elixir processes work is that if you have two nodes, like you're saying you want to scale horizontally, so at the point where you're like, okay, but, and I want to come back to this, at the point where you need another process, the Erlang VM and Elixir basically have built that on the foundation. So you don't need to, like, your PubSub you can just send to that topic, and if the subscriber is on another node, you don't have to care. Like, it's just going to work, that was like mind-blowing for me. Our app, and the next thing, the immediate follow-on to that is that you will scale Elixir vertically much further than you will traditional web languages. So there's an interesting article. Well, Discord is using Elixir at their company, and they've written a bunch of blog posts about how they've scaled Elixir to handle 5 million concurrent users. And I don't know if they talk about horizontal scaling, but basically they're squeezing the juice out of Elixir and the Erlang VM. Does that answer your question, Jonathan? Like, it's easily distributed by its nature. Like, it's built in to the VM in the language. So when you say redundancy, do you mean like if one of those new nodes goes down, or do you mean in the message multi-zone in AWS? Yeah, I mean, from that, yeah, that's fair. So like you could just run one server, and then if that server gets like taken down because somebody trips over a cord, what are you going to do, right? Is that kind of where you're getting at? Yeah. Yeah, I mean,
I can
yep,
take that
please.
one, if you don't mind.
Yep.
So like a good battle-hardened Elixir deployment is an Erlang. It's like a traditional Erlang deployment, which means that it's out of the box, like a distributed cluster instead of like traditionally with a like stateless web server, you just scale up new. There's a little bit of instrumentation, or I guess work around ensuring that your cluster can talk to each other, and then there's libraries that make it easy for those to be self-healing, and sort of like you get into the like distributed state and like management of like consensus-based I can't remember what I can remember the implementations of these, but like Raft is the Raft algorithm is an example of like consensus-based distributed state where like certain nodes will be up and certain nodes will be down, with that eventual consistency but from that. So like in an AWS deployment, you'd put a load balancer in front of your cluster, and you can put that in, you know, the that you're running or something, and they can discover each other via like DNS or the sort of like built-in other ways of making them aware of each other. That's a super complicated answer, but basically you run a cluster of servers, know about each other.
Yeah, some of the tools you'd have.
It doesn't matter.
Some of the tools you have to reach for, like Zookeeper, if you needed to do service discovery, some of those other things, right? Like suddenly you're getting into like a bunch of weird stuff if you really need to start sending messages back and forth. And this is all there. I don't know, like one thing, Matthew, you were saying is like, I don't know the algorithm that they use for doing that work, but like I know Zookeeper uses Paxos, and Raft is the one that's like easier to understand. That's basically what I can say about that. Cool. Any other questions? I'm gonna give it. No one's typing. If you have a question, just like hit something into the keyboard and hit enter. Otherwise, we're gonna wrap it up. I think we're out of time.
We're out of time, but there's no other session. It's just the end for today.
Fair enough. Okay. Well, really quick. There's like actually more slides, which I won't show, but I would like to say a huge thank you to Matthew Lenner, who's been helping answer questions today. He's also my boss and doing a great job. Sam Willis, Mark Zombor, and Aidan Rani are my teammates who have really helped me understand some of this stuff at a much greater depth than I would have been able to otherwise. If you have additional questions, feel free to reach out to me. I should have put my email address. Well, I don't know. I'll put my email address on the slides or something. I don't know. I'll type
in chat right now too.
Let's do that. There, send me questions there, and I'll get back to you. And if I can't answer, like a lot of this stuff is like, I don't know. Let's go find out. I can ask some of my friends and colleagues. All right. Thanks, everybody.
Thank you so much.
All right.
Thank you yourself.
Bye.